Hello, so here we are with the second lesson. Today you'll be solving systems by graphing things yourself. Yesterday we kind of saw what it looked like when it was already graphed. Today you're going to have to graph things yourself. Let's start with this very first one. So it says the graph of y equals negative 2x plus 1 is shown below. Draw a line on the same coordinate plane, then write the solution of this system of linear equations. All right, so we get to draw whatever other line we want. So let's start at negative 2 and then go up 1, right 1. Up 1, right 1, up 1, right 1. And so that's going to be our second equation, our second graph. So I'm going to go ahead and draw in my line from there. And then we just have to look and see what exact point they're crossing at. We want to make sure that they're crossing at a good point so that we can read it. Sorry, I'm just lining up my ruler. There we go. So that equation started at negative 2, then went up 1, right 1. So let's write that second equation would be y equals, the slope is 1 over 1, positive 1, x, plus the y-intercept is negative 2. So there's that second equation. And this point where they cross is right here. So the solution would be 1, negative 1. All right, let's do the same thing over here. It says the graph of negative 4x plus y equals 4 is shown below. Draw a line on the same coordinate plane, then write the solution to the system of linear equations. Okay, so I see this one has an x-intercept. If I covered up the y, it would be x would equal negative 1. So it's crossing at negative 1 here, and then y equals 4, so it's crossing at 4 here. All right, so let's go ahead and write another equation, and I want it to hit this other graph right here. So I'm going to pick that point, and I'm going to go from there, up 1 over 2. All right, so that equation is going to be, it went up 1 over 2, up 1 over 2, up 1 over 2. So I'm going to say that equation is y equals 1/2 x, because it went up 1 over 2, and it's going to cross at negative 3, so that's 1/2 x minus 3. And then I'm going to put another point there. Here we go. Let's draw the graph. So today we're drawing in our own graphs, and then we're going to name the point where they cross. So this cross point that I chose was right there, and that cross point would be negative 2, negative 4. Okay, so that would be the answer to the system because that's the one and only point that works for both. That's the one and only point that is on both lines. So let's see what it looks like down here when we have to graph ourselves. So we have to remember slope-intercept form. Let me zoom in so that you can see this a little bit better. I know it's printed a little bit small on this page. So we have to remember slope-intercept form. So for this first equation, I see that the slope, I'm going to go ahead and write in, the slope would be negative 1, and the y-intercept would be 3. So that means it starts at 3 and goes down 1, right 1, down 1, right 1, down 1, right 1. And goes downward like that. So let's line up our ruler and graph that line. I'm going to extend that line as far as I can go, just in case I need to to see where it hits the other line. All right, so I'm going to extend that line as far as I can. On the computer, this will be a little bit easier. Second line, slope-intercept form. I see the slope is negative 1/2. The y-intercept is 1. So this one's going to cross at 1 and then go down 1, right 2. Down 1, right 2. I didn't hit it yet. Down 1, right 2. Oop, there it is. But I'll do an extra point. Down 1, right 2. Now I line up my ruler there. Now that I've graphed both equations, I can easily see where they meet. I can easily see that cross point. I even saw it as I was drawing it. That helps when you're drawing. On a computer, you have to look a little harder. So this has a cross point, so that means there is one solution. So on the computer, we would choose one solution, and we would write that solution as an ordered pair. That's crossing at 4, negative 1. Now remember, we should be checking our answer to make sure that that is a point that's on both equations. So I'm going to plug in 4 for x, negative 1 for y. In the first equation, that would give me negative 1 equals negative 4 plus 3. Negative 1 would then equal negative 1, and that checks out for the first equation. Second equation, it would give me negative 1 equals negative 1/2 times 4 plus 1. That would give me Well, half of 4 is 2, so that would give me negative 2 plus 1. And negative 2 plus 1 is going to give me negative 1. So it checks out for the second equation. We now know that we are correct. That was the correct graph, and that is the correct solution. All right, let's try that for this one. Again, I'm not going to write out the m and b this time because you should remember that form. This one starts at 2, then goes down 2 over 1, down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. The more points you have, the easier it is just to line up your ruler to make sure that you're lining that up correctly. When you do this on a computer, it's a little bit easier because you know it's being lined up the right way. Second equation starts at negative 3, then goes, it's positive, so up 1, right 2. Up 1, right 2. Oop, I already see it. Up 1, right 2. Up 1, right 2. All right, let's line up the ruler, but we can already see that point where they cross, that one point that should be in common for both lines. That answer is right there at 2, negative 2. 2, negative 2. So I can tell this has one solution because the lines cross, and I'm saying that solution should be 2, negative 2. But remember, we should check. Let's go ahead and label this a check. Equation number 1 was y equals negative 2x plus 2. So if x is positive 2 and y is negative 2, this equation would turn into negative 2 equals negative 2 times 2 plus 2. Wow, that's a lot of 2's. So that means I would have negative 2 equals negative 4 plus 2, and negative 2 would equal negative 2. So that checks out for the first equation, but I have to check the second. So here's the second equation. Instead of y, I'm going to write negative 2 equals 1/2 times, instead of x, I'm going to write positive 2 minus 3. So that means I would have negative 2 equals half of 2 is 1 minus 3, and 1 minus 3 is negative 2. So that checks out for the second one. So that means our answer is correct. All right, let's move on. Back page, same stuff. Oh, but here's one of those standard form equations. So remember, there's a couple of different ways we can graph this. If you can see the y-intercept and the slope-intercept, then we can start with that. But I see that on this first equation, if I cover up the y, it's going to say negative 3x equals 8, and that's going to result in a fraction. That's going to be pretty hard to graph. So instead, let's focus on changing standard form to slope-intercept. So I'm going to work that out over here just because there's space here. Negative 3x minus y equals 8. I'm going to draw the line, circle just the y. And to get rid of the negative 3x, we're going to add 3x to both sides. That means I would have negative y equals 3x plus 8. My last step would be to divide everything by negative 1. So in doing that, that first equation becomes y equals negative 3x minus 8. Negative 3x minus 8. So that means it's going to start down here at negative 8 and then go down 3, 1, 2, 3 over 1. Well, that one's really hard to graph. Sorry, you couldn't see that. Starting at negative 8 going down 3 over 1 is kind of hard to graph because it goes off the graph. So instead of going down 3, right 1, we could go up 3, left 1, up 3, left 1, up 3, left 1, up 3, left 1. So that's another way we could graph this negative slope if we run out of space. And I'm going to go ahead and connect those points. So there's the first equation. Now the second equation crosses at negative 3. It's a little easier to see this one. And then goes down 3, right 1. Down 3, right 1. Sound familiar? Down 3, right 1. Or the opposite, up 3, 1, 2, 3, left 1. Up 3, left 1. And I'm going to go ahead and graph that. So that should have sounded familiar because these slopes are the same. And what do we know about things with the same slope? Are those lines ever going to cross? No. This one is a no solution. And we can write in, it's because they're parallel. Same same slope. Okay, let's move on to the next one. Again, let's go ahead and focus on changing standard form to slope-intercept. I just think it's easier to graph. So I'm going to copy that down over here. Negative 3x minus 2y equals negative 12. I know the hole punch is right there, but we can still solve this. So I'm going to add the 3x to both sides. Add 3x. So we're going to get negative 2y. And sorry, I'm going to kind of mess up my line of equality there just for sake of space. These are going to go away. We have negative 2y is going to equal 3x minus 12. And then my last step would be to divide everything by negative 2. Divide everything by negative 2. So we get y equals negative 3 over 2x plus, because a negative over a negative is a positive, plus 6. All right, so that tells me I'm going to start at 6 and then go down 3, right 2. Down 1, 2, 3, right 1, 2. Down 1, 2, 3, right 1, 2. Down 1, 2, 3, right 1, 2. Okay, so I got a few points on there. Let's go ahead and connect them now with the ruler. And I can see my first line is there. All right, now for the second line. That one's already written in slope-intercept form. And it says start at 6. Well, I've already got that point. Then go down 3. Oh, there you are. Start at 6, then go down 3, right 2. Well, if I do that, I'm going to hit every single point on here. It's just going to be the exact same line. And so that means it's going to cross an infinite amount of times. So that's what it looks like when there's an infinite number of solutions. All right, let's go on to this last couple of problems. These are a little bit easier to graph. This very first one starts at 3 because it's slope-intercept form. Starts at 3, then goes down 2 because it's negative. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. All right, so there's the first line. I can see that. The second line is written in that weird form. So the second line is written y equals negative 1. So the only rule for that line is y has to be negative 1. So I'm going to put a point where y is negative 1. And I want to remember, so remember that was negative 1, 0, negative 1, 1, negative 1, 2, or sorry, negative 0, negative 1, 1, negative 1, 2, negative 1, 3, negative 1. Remember with the XY table, if you wanted to make that, if you remember, y equals negative 1, the only rule is that y has to be negative 1. The other points can be whatever we want. And then you plot those. So what ends up happening is it's a horizontal line going through where y is negative 1. So if I draw in that line, then I can see where those lines meet up. All right, so there's y equals negative 1. That's the line for that. And I see that they meet up right here at 2, negative 1. So that would be one solution. Now, when we plug it in, obviously y equals negative 1. My y is negative 1. That's the only rule, so we get a check mark there. For the first equation, let's check. Remember, this is x and y. So for y, I'm going to fill in negative 1 equals negative 2 times the x is 2 plus 3. So that means I get negative 1 equals negative 4 plus 3. And negative 4 plus 3 is negative 1, so it checks out for the first equation. All right, last example that we have to graph ourselves. It's another one of those weird ones. Let's start with the easy one. We're going to start at negative 1 and go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So there's the graph of the first one. It's hitting all those corners because it's just got a negative 1 slope. So it's going that way. And then x equals 2. Remember again, if you make that xy table, the only rule is that x has to be 2. And y can be whatever we want this time. So if x is 2, y is 0, x is 2, y is 1, x is 2, y is 2. So we get a vertical line. So that one's undefined. That line is not technically a function because it's repeating their x's, but it is still a line. And so we can still tell what answer they would have in common. It's right there at 2, negative 3. So my one solution is 2, negative 3. And so to check that, I'm going to plug that into the first one because obviously the x is positive 2, so it works for that one automatically. For the first one, though, let's plug it in. Remember, the y is negative 3 equals negative x is 2 minus 1. So negative 3 would equal negative 2 minus 1. And that does come out equal to -3. So it checks out for the first one. All right, that's it today. Have a great day. Yay, math.